I call this one hover wall down. It's a really simple one to set up, kind of a fun effect, and I think possibly a small mechanic of a game or a fun show or an interactive kind of like VJ wall or something. The way that this works is my cursor comes over one of these cubes and makes it glow and suddenly activates its physics, basically enables its rigid body to accept physics. And you can do this with a VR, laser pointer, and when it hovers over, or here with the cursor. You could imagine similar kind of things. Now, they wouldn't have to attract; they could also repel, and other things could happen. You can see that eventually we've covered ourselves up completely. So you could have potentially your right hand with a VR, like make these things come towards you, and left hand make them go away, or do all kinds of things. But let's set this thing up. It's a pretty simple thing to set up, but so I'm going to show it to you, and it is available on the here. You can find this one here on called Hover2Summon, and that's under the Explore menu here in the Explorer browser. It's under Featured. It's called Hover2Summon, and I'm going to show you how to build it right now. I'm going to start with a new scene. Save changes, and no. So to set this up, what we have is cubes that have some that come in just as they are naturally here, with a rigid body that is active and set to movable. And we're going to basically set it to immovable, and then basically say, when I hover, become movable. And the last thing that we're going to have is this little toy here, or a tool called Attractor. And the Attractor is here under Physics, and I'll just show you what it's doing in normal playtime. It's basically putting a constant force on this, kind of like a gravitational force, onto all the rigid bodies in the space. It goes and queries them, and then it adds a force that is essentially in the kind of inverse vector, in the vector differential between the two of them. So wherever this is, if it's far away and it's over here in this direction, the Attractor node puts a force on it. And I think that we use the inverse square of the distance. So, and you can find that this Attractor node has a little code under it. It's just a node, entities node, which is just kind of a blank, kind of non-spatial well, it is spatial. It lives in the space, and it has script on it. So if you right click on it, you can hit edit code, and you'll see that what the code in here looks like. And we've prepackaged it to you, so you don't have to know what this is. But basically, you get this juicy little loop right here that loops over all of the nodes in the space. So we go get all of the nodes in the space, including this cube, and then we go and get for each one of them, we get their rigid body, and then we calculate the distance to that node and figure out the direction, and then get some little scalar based on the inverse square, and we apply a central impulse. And I said constant force in the beginning, but technically it's a central impulse. It's creating an impulse at every frame on every object in the direction between that object and the attractor, and it takes into account the object's mass. And you can even make the force stronger here by putting in some kind of scalar here. So multiply by 10, and you'll see it zipping around much faster. I can edit this code here and drop this back down to I don't know. How crazy will it go at 100? Yeah. Okay. You can see it going crazy at 100, but we're gonna knock it. We're gonna keep it at its normal or its original value. Okay, so that's kind of the physics at play. So let's set this thing up. So first, what we're going to do is take our original cube, and we are going to first what we're going to do is set up the script, and then we're going to make a number of copies, and we're not going to make shared copies. We're going to make what's called a whole copy, and I will show you that now. So to set up the script on this, what we're going to do first is apply an interaction and a hover. We're going to put down here, you've got two hovers. The glow hover will work on things with rigid bodies. So we'll put the glow hover on it, and then in playtime I'll show you what that looks like. If we hover over it, it glows, right? So in stop time, let's look at the properties here. One of the things that we've just added is this interactable attribute using these interactions over here. That interactable attribute shows up, and now it's got all of these events. This box entity has an on press event. I would click it. Oops. If I'm pressing it and holding down a click, and again, this works across the mouse and for 2D kind of screen-based interactions, as well as the laser pointer system in VR. It's got a on pressing, and on release for mouse or VR controller buttons. Hover on or hover off. So if the laser or the mouse goes over it, and so we have now a hover on. The hover on basically lives down here in this little node. And so this one actually has the hover on event right here. So what we're going to do is very simple. We're going to say, we're going to basically have this box have its rigid body be set to false, so that in playtime, let's put the attractor in, physics, attractor. The attractor does not work. And then when we hover over it, what we want is for the the rigid body dot movable to be set to true. So to do that, we're going to select the box, come to the object script, and hit edit code. We have our on hover event, and this lives on our box. So what we're going to do is reference ourself, and then to get our rigid body, that's to basically the script lives here, and we are asking for our rigid body. We want to get it this property, so we have to get rigid body, and over here in the script window, open close parenthesis runs the function get rigid body, and then the property on using the dot operator to get the property dot movable. And these are all camel case, so lowercase first word movable equals true. And that will mean when I hover over it, it becomes true. Now, you might be thinking, oops, I need to set this to false in the beginning. So the box should be false at the beginning of playtime. Its rigid body movable should be set to false at the beginning of playtime. And then when you hover over it, it should become true. Well, the effect that I wanted was that it only is active when I'm hovering over it. I only want it to move when I'm hovering over it. So what we need is one more piece of script, which we can find on this event, basically when we hover off. So we hover over it, it makes the rigid body movable. When we hover off, it should become immovable. So we'll basically take this same script and just change this to false. So that's the hover on. Self get rigid body dot movable is true. Hover off. Self get rigid body dot movable equals false. And so now it only works when I'm hovering over it. Good. This is what we want. So I'm going to put it down on the ground, and then I'm going to come over here to the side, and I'm going to make a clone of it. So to do this, I'm going to hold down Alt, and while I do Alt, I'm going to holding down Alt. I'm going to left click my mouse and move my move my mouse to the side, and I'm going to basically hold down Shift as well to kind of constrain to this ground axis. Then I'll grab 2 and hold down Alt and Shift and pull to the side, and then I'm going to hold down Alt and Shift, pull to the side again. And now I'm going to do the same thing. I'm selected on this part of the transform widget. I'm going to hold down Shift and Alt and come up. Shift and Alt and come up. Shift and Alt and come up. Now I've got all of these, which should react just as we've planned. And we may want to move, come up here, you can see it. We may want to move the attract widget over here. Or Attract Node. This is kind of cool, but if, like I showed you earlier, if you want to make this come out more powerfully, right click on the Attract node and hit Edit Code. And right here at the final place where the rigid body of each node, we're going to apply the central impulse in that direction, multiplied by the mass, and multiplied by an inverse square scalar. And what we're also going to add is just a little bit more force, just to make these things kind of more reactive. And now you can kind of see them jumping out a little bit more, more quickly. So if I pull this back, so there you go. This is basically, and then what I did is I put, in the other show, I've put it a little later in the day. Clicking on the sky space, I put it a little later in the day, so you get these kind of shadows and the light lights up. And I think I even threw in a light. I threw in maybe a spotlight and then kind of like rotated it into place, because then you get a little bit more exaggeration of things passing through the kind of passing through this space, and maybe exaggerate the shadows. Yeah, there, something like that, or maybe off to the side slightly. Kind of. I just moved everything in playtime, so I'm going to Control T, commit transform changes on the attractor. Okay, so now find a spot to kind of present this, and press present, and interactions work in present. Camera motions don't unless you've chosen how to make those happen. And we could make the background completely black and light this up, and then make it kind of like an interactive wall. Having these things go in the opposite direction would be kind of interesting. I mean, imagine you did projection mapping or something, and you want these objects to look like the bricks, the cinder blocks, or the bricks of the wall. And then as you touch them, they disappear. They kind of crumble and fall back. One thing you could do is, instead of this being in the code of the attractor, you basically just need to make it go the other direction. So a negative sign will actually turn an attractor into a repeller. And so these things kind of run away from you. Kind of helps to be up close, but almost a more interesting effect in some ways, seeing these things disappear to the back. And interestingly, you might be able to kind of control the light, so they might go through different. They might go kind of through like a spectrum of light. You could project, this guy could potentially come over here, and you could basically clone off a handful of these, and then just like make this red, or wait, let's see, red, orange in the middle, maybe. Let's see what this looks like. I just clicked cast shadows. I kind of do want it to cast shadows. Maybe make this one orange, red, orange, yellow, green. Just go for the whole thing here. How about it? Green, blue, delete this one. Where do we end up? One of the cool things you got here potentially is, let's actually get these up a little higher, sorry. Got horizons. So we could put a night full moon horizon in place. What other horizons might we want? See what it looks like on the moon. How's this look? Get the Earth over there, sun up there. A little bit of ambient light here. Well, they do kind of light up, yeah, as they get farther back. I don't like that. I feel like we might be, something like that might make more sense. Anyway, this has basically been a tutorial on some simple interactions and a little bit of physics, and kind of setting up a scene. And I called this one, what did I call this one? Hover2Summon, or it's pretty enjoyable. It's pretty satisfying to. You could also animate, just, a final thought, you could animate the amount of time. You could set a timer for how long that rigid body stays, its movability stays active. So you could hover over it and basically trigger a timer, at which point the rigid body remains movable, but only for a certain amount of time. And so it wouldn't be, I guess it would sort of run for a little while longer on it. You get a little bit more time, a little more distance for each hover. It's pretty cool. Hope you enjoy it.